Hello and welcome to the extended version of the Deciphering Data session. My name is Dave Glover and I'm a cloud developer advocate based in Sydney, Australia with a focus on the Internet of Things. Now this session is a follow-on session from the Deciphering Data Architecture session, and in this session we're going to have a combination of presentation and demos, hopefully to help you better understand how you can go and build an IoT solution with Azure. Now in this session, I can't possibly cover every scenario, but what I'm going to try and do is demonstrate and show commonly used IoT patterns in Azure. Now the agenda for this session, we're going to talk about Azure IoT Services. We're going to look at options for stream processing. We're going to look at data visualization with PowerBI and plug and play and IoT Central. So the first thing we're going to look at is Azure IoT Services. Now, as a quick recap from the Deciphering Data Architecture session, remember we have essentially three components that make up an IoT solution. We've got things that generate data, we've got insights built on that data, and we've got actions built on insights. So let's talk more about things. So we've got IoT devices that are capable of directly connecting to a cloud gateway, and we've also got devices which we might need to connect via a gateway, be it a field gateway for constrained devices or a custom cloud gateway for devices in other clouds. And we've also got intelligent edge devices providing ability to go and run things like machine learning models or do local stream processing. Now remember, if you're a developer, you should be thinking about message types. Are we sending telemetry messages or alert messages or other types of messages? The data types, is it simple text or are they binary? What serialization we're going to be using, JSON, Avro, protobuf, etc. And remember, it's very important to add metadata to these messages because this significantly simplifies the data processing in the cloud. Next, we've got the insights, and of course we want to do things like stream processing of the data as it's flowing into the system. We invariably will need to do data transformation, and of course we want to store that data. And we want to think about the volume and the value of the data, as this will guide us as to where we're going to be storing our data. Are we going to be putting it in a warm path or a cold path? There are performance and cost implications of doing that. And then finally, we've got actions. So invariably what we want to be able to do is integrate those insights into our business systems to maybe help us make better decisions based on data, or maybe opportunities to automate. And of course, we would like to be able to do things like batch analytics, or maybe train a machine learning model that we could then go and deploy into the cloud, or maybe deploy onto the edge to provide local intelligence. Okay, next we're going to talk about how you go about implementing an Azure IoT solution. Now the scenario I've chosen is a smart factory. The reality is the services and patterns I'm going to be discussing are really applicable across a whole wide range of IoT solutions. So as we know, we've got things that generate messages, and those messages will send a message to a cloud gateway. Now in the world of Azure, a cloud gateway service is the Azure IoT Hub service. Now, IoT Hub is an internet-scale secure messaging service. It supports bidirectional communications. It supports message enhancements, enrichment, I should say, and partitioning. Now, I'm going to talk about message enrichment and message partitioning in more detail shortly. Now, as that data flows through the system, we want to do stream processing on that. And these are common services that you would use for stream processing. So, for example, there is Stream Analytics. There is Apache Spark Streaming, which is part of Azure Databricks, and there is Azure Functions, which can all be used, common services used for stream processing. And then invariably you want to be able to store that data, and these are common services that you would go and use for storing data. You've got Azure Storage, Cosmos DB, putting data into an event hub and things like that. And then the actions behind this is that you would be able to go and then use the insights that you've generated or built for driving things like smart reports to better understand how your IoT data is flowing through the system, and maybe to be able to make better business decisions on that IoT data. Or maybe you want to go and integrate that data using things like logic apps, which are low-code, no-code options, and you're able to integrate the data that's flowing through the system, the IoT data flowing through the system, and integrate that with back-end business systems. And then ideally you want those back-end business systems to be able to make decisions, to then be able to send a message back through IoT Hub, back to your smart factory, down to the device or into the device in the factory to say, hey, let's turn off the air conditioning system because the factory is closed for the day. Now, as I said, I'm going to talk about these in more detail, all this in more detail. So the first thing I want to talk about is message enrichment. So you can see on the left-hand side, we've got a JSON-based message that the sensor device that's monitoring an HVAC system. So an HVAC is a heating, ventilation, and air conditioning system. And you can see that the device developer has captured the telemetry, the humidity, and the pressure from the HVAC system, and the device developer has also added in some metadata. So the properties that have been added, we've got an app ID of HVAC, the type of message is a telemetry message, the format that the data has been serialized in is JSON, and the schema version for this is 1. And that message will flow into Azure IoT Hub. Now, before I go too much further, I want to talk about another concept, which is called a device twin. Now, every IoT device that is registered with Azure IoT Hub has a device twin document. Now, a device twin document is a JSON document which has metadata in it, which can be used to describe the device or describe the device. And in this case, we've got tags. And you can see in this tag, I've got deployment location. So in this case here, I'm saying that this device is named Sydney Factory and the longitude and latitude have been recorded. And the idea, the way this would work, is that you would go and deploy the sensor into the factory, and then you'd have a process, an application that would then say, okay, this device has been deployed. Now I need to update its device twin document with this information, this additional metadata about this device, because now we know which factory has been deployed and we know the longitude, latitude, etc. So that information goes into the device twin document, or this JSON document. Now I can use the tag information, and I can use that for message enrichment. So what I can do in Event Hub, I can say this, as these messages flow through, I want to enrich these messages with data that you can find in the JSON document, in the device twin document. And you can see on the right-hand side, I've got that message which is flowing through. I've got the body of the message is clearly the same. And you can see that there are 3 new fields added to that message. I've got name, latitude, and longitude have now been added to that. And now I've got that metadata attached to that message as it's flowing through the system. And that can now become very useful metadata, for example, for driving reports or maybe partitioning data or doing a whole range of things. Okay, so the next thing I want to talk about is message routing and partitioning. Now, if you think about the smart factory, that smart factory is going to have a whole range of sensors. It's going to have sensors that are monitoring the HVAC system. It's going to have sensors that are monitoring security systems or lighting systems or process systems or production line systems. There's going to be a whole range of sensors that are monitoring activities that are going on inside a factory. Now, what you need to be able to do, and of course, all those messages will have different application endpoints. They'll have different schemas. They might have been serialized in different formats and things like that. So what we need to do is to separate out those messages. Now, normally the use case, you probably separate out by application. You'd say, okay, all the HVAC messages, I want to partition those messages and I want to store those in a queue, which is for all HVAC messages. The same deal would be for security messages. Hey, look, all the security messages that come through, I want to store those all in another location. The lighting messages, the production control systems, etc. You want to basically separate out that data. And normally you probably do it by application. But you could do it by location or device type or the message type. Is this a message, telemetry message, is this an alert message, etc. So what you can define in Azure IoT Hub are rules-based, as basically using rules for message routing. And you can see an example here. So I've got a rule that I've set up called app ID, where app ID equals HVAC, and the type of message is telemetry. So as those messages flow up through IoT Hub, I've got these routing rules that get applied to all these messages that go through, and I can start separating or partitioning out these messages. So in this case here, this was an HVAC telemetry message, and the rule was true, and I then forward that message into an HVAC telemetry event hub. The same deal would be for a message that came from a security system, in which case the app ID would be security, for example, and then I would know to route all those messages off into a security telemetry event hub. The same deal for lighting, and I might want to go and say, well, all messages that come into the system, I actually want to put those into Azure Storage as an audit, and I would normally put those into a cold path, something like Azure Storage. I've got a lot of data, huge amounts of volumes of data, and I need to be able to store it, but I probably don't need to be able to query on that data or have a readily accessible access to that data. So you'd normally just go and put that into storage. It's a very cost-effective way of storing large amounts of data. Okay, so the next thing I want to talk about is stream processing. So we've enriched our data, we've now partitioned our data, and in this case here, we're just looking at the HVAC data. So the data that's coming through from the heating, ventilation, and air conditioning system. So in that event hub, I have got a whole lot of messages that have been flowing through that system. So I've got these HVAC telemetry messages that are now going into my streaming process system. So as I mentioned before, these are the common services that you might use for stream processing in Azure. So there are broadly three. We've got Stream Analytics, we've got Apache Spark Streaming, and we've got Azure Functions. Now, I'm going to kind of give you a rough rule of thumb where you might use each one of these services. So if your requirements are relatively kind of normal, and your experiences are really quite data-centric, so the skill set, for example, in your organization, you've got a lot of database skill sets, then Stream Analytics can be a great choice because it's very SQL-oriented. I'm going to drill into this in a bit more in a moment. So you'll see that the techniques and the skill sets that you'd require to go and query a database are the same skill sets that you'd use to query data that's in flight and moving through a system. Now, Databricks is more data science. So if you already invested in Apache Spark and Azure Databricks, then maybe your skill set inside your organization is more geared towards Databricks and more data science oriented. Then it makes sense to go and use the Spark streaming capabilities as part of Databricks to go and do your stream processing. Now, if you're more developer-centric, then Azure Functions are great because they provide a very cost-effective way of having data coming through a system and being able to process that stream or process that message. Maybe you want to do some transformation of that message and maybe go and store it in various locations. Now, the other way that I like to think about stream processing is stateful and stateless. Now, the first two, Stream Analytics and Databricks and Apache Spark Streaming, are stateful-based stream processing. So, for example, they are capable of streaming and averaging. Let's say I want to average data over a period of time. Let's pick 5 minutes. So we've got maybe thousands of messages coming into these stream processing systems, and I want to maintain state for 5 minutes of all those messages that are passing into that system, and I want to go and average the temperature, for example, of all those messages. I'm more interested in the aggregate form of those messages rather than the individual messages. And that's where stateful processing of stream processing can be very useful, and that's where Stream Analytics and Databricks kind of excel. Now, Azure Functions are much more about being stateless. So you've got a message coming through, it deals to that message, it doesn't understand the context of this message versus all the other messages that are flowing in from the HVAC system. It just understands, hey, this is a message, I'm going to do some, transformation on that message and then pass that message and store that message somewhere, or maybe pass it into another queue. So that's kind of hopefully roughly a rule of thumb. So you've got Stream Analytics, which is more SQL-centric. We've got Databricks, which is more data science-centric. And we've got Azure Functions, which is more developer-centric. We've got Stream Analytics and Databricks, which are more stateful-based stream processing. And we've got Azure Functions, which are more stateless. Okay, so hopefully that's clear. Where you might use those streaming technologies. And then, of course, you want to be able to store or process that data and pass that data out through that streaming process. Now, this really comes down to where you store this data, really comes down to the value and the volume of data that you're dealing with. Now, if you have a large volume of low-value data, you would normally go and put this into your cold path storage. And in Azure, this is Azure Storage, and it's very cost-effective storage for storing large volumes of data. And you would then be able to use that data maybe for training machine learning models or batch analytics, or maybe for audit process or things like that. The other place you might want to go and put data is into the warm path. So the example I've got here is Cosmos DB. And warm path is much more about interactive reports. So this store is normally quite what I call queryable. You can define queries against that and get data back in a short amount of time. So Cosmos DB is a NoSQL solution, but there's nothing to stop you using something like SQL Server or Oracle or whatever it might be as a back-end data store for storing this data in a warm path. In this case here, I'm going to be using to drive reports. But of course, it could be for business integration and things like that. What I would strongly recommend is really think about your data. I've seen solutions where the developers have decided to go and put all the data into the warm path, audit data, everything into the warm path, and that can result in a lot of issues, performance issues. You've now suddenly got a database which is bulging with data and then really can't do the things that you really want it to do, which is normally interactive reporting or business integration. So you want to make sure that you separate out, and the other issue with that is it can get very expensive. So you really want to think about, okay, this data here, it's audit data. I want to go and put this in cold path. This data here, I want to keep for a limited amount of time, and I want to put it in the warm path because I want to use it for more interactive use. We've got Synapse and Databricks. Both of those solutions are really around dealing with big data or data warehousing. So again, the output from that stream process might be into a data warehousing, big data kind of scenario where you might be going training machine learning models or things like that, or doing large-scale analytics. And the output might also be into another queue. In this case, I'm moving the message into an event hub, and I'm going to use a logic app. And as I mentioned, a logic app is a low-code, no-code solution where you can define basically a set of rules and say, okay, I've got a message here, it's for the HVAC system, and I've got a set of rules here, and this is how I go and integrate this message into a back-end business process. Okay, so what I want to talk about now in more detail is Stream Analytics jobs. Now, as I mentioned before, this is kind of more SQL-centric, and it's a great way to get on board with stream processing. So you can see over here on the left-hand side, I've got two inputs. So I've got the input that from the that I partitioned into the HVAC telemetry queue. So that's one input. And I've also got some reference data. In this case, the reference data is weather data. So what I do is I have a job, an Azure function that I run every 15 minutes, which goes and grabs the current weather conditions around the factory on a 15-minute basis. And the idea behind that is I'm ultimately going to join that weather data with the telemetry that I've got from the sensor that's monitoring the HVAC system in the factory. I'm going to join that data together, because I thought it might be interesting that if I knew the outside temperature of the factory and the inside, then maybe I can start making smarter decisions about what I do with the HVAC system, the air conditioning system inside the factory. So for example, if I know the temperature's dropped by 5 degrees outside, then maybe I can start making some smart decisions and reduce the air conditioning level inside the building because I know that the outside temperature is dropping. And then what I do is I have a query. So in this case, I said the query looks really like SQL, and I'm going to show you this in a moment. And basically, that as that data is flying into the system, you can run a query against that data. And for example, you can aggregate that data. I'm interested in the average temperature of the data that's flowing into the system over a 5-minute period, for example. Okay, so the output of that query, which is doing this aggregation, I'm actually passing that into 3 other queries. And what the first query, what that's going to do is I've got an alert query, which says, hey, if the temperature goes above 40 degrees Celsius, I'm going to send an alert message because I want to send that message into a service system to say, hey, look, the HVAC system needs to be serviced because the temperature has got unacceptably high inside the factory. The other thing I'm going to do from the output of this first query into the second query here is what I'm going to do is I'm going to join the telemetry data with the weather data. And I'm going to write that joined data into the HVAC Cosmos DB data store. And you can see I'm doing the same principle here is I'm going to join the weather data with the telemetry data, and I'm going to store that into the HVAC storage. Maybe I'm going to use that to train a machine learning model or use batch analytics against that at some point in the future. Now, as I mentioned before, Stream Analytics is very SQL-centric in its approach to dealing with data. So in the same way that you're going to define a SQL query against a relational data store or a NoSQL data store for that matter, it's very similar concepts. You say, hey, look, I want to select, and these are the fields I want to select. I want to describe where this data is coming from. So you just say, hey, look, this data is coming from the HVAC telemetry event hub queue. I want to say where in this case here, I want to say where the version of this telemetry message is version 1 of the schema. And then I want to do a group by. And in this case down here, what I'm doing is I'm doing a group by, but with a tumbling window. In this case, I've set it to 1 minute. So what's going to happen is I might have thousands of messages that are appearing on this event hub that I'm going to run through the stream processing. And what I'm going to do is average those messages that are flowing in that system over that 1 minute. So I've got thousands of messages coming in, and I'm interested to aggregate that data and come up with the average temperature, the average pressure, the average humidity on a minute-by-minute basis, because that's more interesting. And in fact, probably it would normally be more like 10 minutes or 15 minutes or an hour or whatever makes sense for the business scenario. Okay, so kind of end-to-end, hopefully that made a reasonable amount of sense. So we've got things generating data. That data is being sent to Azure IoT Hub. IoT Hub has the ability to go and enrich messages. In the case I used was, hey, look, I want to go and enrich that message from that device with its geolocation. I want to go and partition out those messages because remember that from that factory, I've got messages coming from a wide range of sensors, all really targeting different applications. They have different schemas. They might be encoded in different methods. And I need to basically separate those out. So that's where you go and use message partitioning. I've got stream processing because maybe I'm interested in the aggregate values of data, might be more interesting, or maybe I need to change the shape. Maybe I've got messages which are coming through from one schema, but I need to store them with a different schema, and I might want to be able to transform that data as it's moving through the system. And then, of course, I've got endpoints for storage. So again, really emphasize, think about your data. Is this data really cold path data, or is this more warm path data? Do I need data for more interactive reports, or am I interested in storing this data for long term? I need cost-effective storage, in which case I'll use cold path. Is this data destined for data warehousing or big data analytics? Or is this data destined to go into another part of a business process? So the data might go into an event hub and then be passed through into a logic app and then integrated into a back-end business system, which will then be able to make automation decisions, for example, to send it back through IoT Hub, back down to the device to be able to control that device from the cloud. Okay, so that's the end of the slide session. So what we're going to do now is a demonstration about how this all hangs together. Okay, so I'm going to start this demonstration from the Azure Management Portal, and I've actually gone into the IoT Hub Management Blade. And you can see in here, I've got various monitoring information. I can see how many messages are flowing into the system. You can look at rates of messages, total messages sent today, etc., number of devices connected. So this is the IoT Hub Blade, and what I'm going to do now is I'm going to go down to IoT devices, and as you spotted, there's only one device defined in the system. It's called Raspberry Pi or RPI-Net Core. And I'm going to go into that device, and you'll find various information about that, key information, connection information, and things like that. But I'm going to go to the device twin. Now remember I said that the device twin is a JSON document that is maintained for all devices that are registered in the IoT Hub. And this JSON document will contain metadata. And the tags section, you can, from your application, you can add data into the JSON document. And in this case here, I have an application which is added in the display name for the device. So I had a friendly name for this one, which is called Sydney Opera House. And I added in longitude, latitude, and the weather location for this device. Now what I'm going to do now is I'm going to go across to Visual Studio Code. And I've actually got a .NET Core application running here, which is connected up to that IoT Hub, and that's for that device. Now this code is available. So there is 2 learning paths I've written to support this talk. So there is the .NET Core IoT learning path, where you can write C# based applications that you can run on Linux, Mac OS, Windows, and Raspberry Pi. The other learning path is your Azure Sphere learning path, and you can use that code base to learn how you'd go and build a C-based application for environments where security is absolutely critical, and that's where you'd use an Azure Sphere device for devices to require high degrees of security. So 2 labs there that you can go through and understand more about how data finds its way from the device up into the cloud. I keep saying up, but to the cloud service. I will have links to both of these hands-on labs in the resources in the back at the end of these slides. So what I've got here is I've jumped back to the CSharp example, which, as I said, you can run on your desktop. Super easy to run, Mac, Linux, and Windows. And what I'm going to do here is I'm just going to step through the code, and you can see that I've got some telemetry come through. So I've got temperature. If I hover over that, the temperature is 90 degrees, humidity is 52, and the pressure is 1190. And what I'm going to do is I'm going to create a JSON message for that. So I've serialized that message into a JSON format. If I hover over that JSON, you'll see there goes the JSON message. And then what I'm going to do is create that message, and then I'm going to add in the metadata properties. So I'm going to say that the metadata for this is app ID is HVAC. The type of message is going to be a telemetry message. The schema version of this message is version 1, and the format of this message is JSON. So I'm using JSON serialization for this message. And then I will send that message to IoT Hub. And this repeats every 2 seconds and will send data up to IoT Hub. Okay, so I've just taken the breakpoint off. So this application is now going to be sending telemetry to IoT Hub every 2 seconds. Now, a useful tool that you can download, just search across the internet. In fact, I'll put this link in the resources, is the Azure IoT Explorer. And this provides a window into IoT Hub so you can start viewing the telemetry flowing through the system. Now, I'm just going to stop that. So you can see here that I'm just going to pause that. And you can see that I've got the message that the device has sent. So I've got temperature, humidity, pressure, and I've put a message ID in there as well. And you can see these are the properties. So the first 4 properties have come from the device. So those are those app properties that I added, that metadata that as a developer I added to this device. Now you will see that this message also has 4 additional properties. It's got the longitude, latitude, weather location, and name. Now that metadata did not come from the device. This data was enriched in IoT Hub. So we're going to talk a bit about that now. I'm going to pop across to IoT Hub, back to IoT Hub, and we'll go to the management blade, and I'm going to scroll down here to message routing. Now in the message routing blade, you'll see that there is an enrich messages section. And what this is going to do, so remember before I showed you the JSON document for each one of these devices. So in that JSON document, there was longitude, latitude, weather location, and name. And remember that application would get there after the device had been deployed, and you'd normally have a management app which would manage the state of that JSON document for this device. And then this is going to be known as longitude and latitude and weather location and name in the data stream. So if I pop back to the Explorer, you'll see that those are the names that are being used, and it's grabbed the data from that JSON document. Okay, so the next thing I want to talk about is routes. And remember, this is where you'd go and separate out the data from different styles or classes of devices. I've got the HVAC devices, I've got the security devices, the devices monitoring lighting, etc. So in this case here, I've only got one route defined. And you can see if I go into that route, you'll see that I've got a query. This is the rule. And it says that if the app ID is HVAC and the type of message is telemetry, if that's true, then I want you to go and route that message to this endpoint. And if I just come up to this drop-down box up here, you'll see that it's going to be the HVAC telemetry. And just going back to the Explorer, you'll see that the message type is HVAC, and I'll just make this a bit bigger, and you'll see that the message type is telemetry. So that's what that is being keyed off. And so that's making that decision, and it's going to that endpoint. Now, if you were keen of eye, you would have spotted up here, I've also got these custom endpoints. And this is where you define all the endpoints. Okay, I want to put all the HVAC telemetry onto this queue. I want to put all the lighting onto another queue, etc. So you would go and define the endpoints in here, and you basically just link those routing rules with these custom endpoints, and that's how the data finds it onto those queues. Okay, so the next thing I want to talk about is Stream Analytics. So I've now got this data which I've enriched and which I've partitioned, and I've sent all the HVAC data onto the HVAC telemetry queue. Okay, so I'm now in the Stream Analytics management portal. And if I scroll down here, you can look at the activity of that portal, how many messages are flowing into that Stream Analytics job, how many messages are going out of it, etc. So I can define the inputs. You remember in the talk I said I had 2 inputs. I had the HVAC telemetry. This is the messages that I've partitioned off into that queue, and I've got the weather data. And you remember I collect weather data every 15 minutes and I store it into storage location, and this is where this data is coming from, and this is just pointing to that data. And I define my outputs. And remember I had an output for alerts, and this will go into an alert queue, which will later get picked up by a service system. Remember I said I had another output which was a Cosmos DB. So in this case here, I'm just defining the location and the security context for the Cosmos DB. And you remember I'm also putting in I'm streaming the data into storage as well. So this is just defining the location and the security context for the Azure storage. And if I go and look at the query, now you can't actually edit the query when the job's running, and the job is running at the moment. This is the query. And as I said before, it's very SQL-like. So you've got your select, from, where, group by kind of notions. And then you'll see if I scroll down a bit further, you can see I'm doing a join by. And remember, I'm doing that join by weather. And I'm joining by the weather ID. So the weather location on the telemetry message, I'm joining to the weather ID in the storage message from the data that I grabbed from OpenWeatherMap. Okay, so that's the data that's running through there. And then I said one of the outputs is going to Cosmos DB. So I've got another blade opened up here, and this is the Cosmos DB management blade. And you'll see I've already got some data items sitting in there from other devices. These are actually from Azure Sphere devices. And if I go and do a refresh, since I've started this and that job is running, if I just refresh on that data, you'll see that now I've got the data in there from the .NET Core application that I'm running on my Windows desktop. But as I said, that application you can run on Mac, Linux, and Windows, and your Raspberry Pi. And you'll see that now I've got my telemetry. I've come in, I've got my temperature, I've got my pressure, I've got my humidity. And you remember, I'm augmenting this, enriching this with OpenWeatherMap data. So I've got my OpenWeatherMap temperature, pressure, humidity, precipitation, wind, cloud, etc. So you end up with quite a rich data that you can start doing some really quite interesting things. And the next thing I'm going to do is I'm going to show you how you can actually use Power BI to report on that data in the Cosmos DB. Okay, so now we've got our IoT data inside Cosmos DB. What I'm going to show you is how you can go and use Power BI Desktop Designer to go and build a report using that data. Now, I'm going to go through this pretty quickly just to kind of give you a bit of a sense of the art of the possible for using the Power BI Desktop Designer to go and build a report. So I'm going to select a data source. In this case, it's from Azure, and I'm going to select Azure Cosmos DB. Click on Connect. I'm going to paste in the URL to that database. I'm going to name the database, which in this case is called Factory 10, and the collection is called HVAC State. Click on Connect. Now, I've already authenticated against this data source, so it won't ask me again. I'm going to click on Transform the Data and expand that data. Now, it's going to bring back all the fields in that data store, and I don't want them all. I'm just going to select temperature, humidity, name, longitude, and latitude, and I'll disable prefix. Next, I want to do a transform on that data, and I'm just doing an auto detect on the columns in this table. It just basically, are these numeric, are they text, are they date, etc. Now we'll close and apply that, and this will take me back to the designer, the Power BI Desktop Designer. And the first thing I need to go and do is I need to tell the system what fields are my longitude fields and my latitude fields for mapping. Okay, and now what I'm going to do is add in a visualization. So from the right hand side, I'm going to click on Map. I'm just going to expand that out a bit. And now I'm going to set the latitude for this map, the longitude, and the value that I want to plot. In this case, it's going to be temperature. By default, it does sum. I actually want the average. Okay, so now I've done that. Next thing I need to go and do is go and set the format. And in this case here, I'm going to select the color, just make it pop a bit more. I'm going to select a scaling factor for the bubbles. I'm going to select the map style. I'm just going to use grayscale. And I'm going to turn on shadow, and I'm going to set a border, and I'm going to set the radius for the border for the corners to be 10, so we get nice curved corners for the map visualization. Okay, so the next visualization I'm going to add in is a gauge, and we'll just drag that up to the top there, and we'll just resize this right about there, and I'm going to set temperature to be the value. Now by default it wants sum, but I want average. And the next thing I need to go and do is just format this, and I'm going to turn the data labels off, and I'm going to set the gauge axes. So the minimum temperature I want to display is 0, and the maximum is going to be 50 degrees centigrade. And I'm going to set 21, which is kind of like a nice comfortable temperature. I'm going to copy this and paste that visualization and just drag this down here and line this up. And in this visualization, I'm going to put in the humidity. And I'm just going to go across to the format painter, go across to the gauge axis. In this case, I'm going to select the maximum to be 100%, and we'll say 50% humidity is going to be comfortable. And in fact, I need to go and set the average for that visualization. Now, the last visualization I'm going to add on is a table, and we'll just drag that out to line that up, and we'll just move that up to create a bit more space. And then we'll select the name field, and we're going to select longitude. Oops, no, we're not. We're going to set temperature and humidity. Okay, so those are all the fields I'm really going to plot. And one other thing I want to add in is a filter for this page. So I'm going to drag and drop name to be a filter on this page. So the next thing I'm going to do is just do a little around just making the report look pretty. And we're going to select on Format Painter, select the map, and then we'll just go and apply the same format that we're using on the map to the visualization for the gauge. We'll do the same for the other gauge, and we'll do the same for the table. And then the last thing I want to go and do is go and select a theme, and we'll go and select a dark theme. Okay, so that's all I need to go and do, and we're just going to do a publish, and we'll save this, and we'll save this as HVAC 11. So this has saved that, and what I'm going to do now is publish this up to my workspace. And what's happening now is that the Power BI Desktop Designer is connecting up to the Power BI portal, and it's published that report. Click on that report to open it. And now you'll see the reports are loading up inside the web portal, and you can see I've got clickable surfaces on there, and I can go around and select different data points, which is kind of nice. And over on the right hand side, you can go and do filters and things like that. So I can go and say, for example, select the home office. So the beauty of obviously of having this report sitting up in Power BI is I can then collaborate with other people or create dashboards or things like that. So it makes a really powerful way of being able to visualize your IoT data. Okay, so the next thing I want to talk about is I think it's a really exciting initiative, which is called IoT Plug and Play. Now, the closest analogy is if you buy a printer and you plug it into your computer, and for example, you can just print from Word to that printer, and you don't have to worry about which manufacturer made that printer. That printer can express its capabilities as a color printer, as a black and white printer, etc. And that's the same concept with IoT Plug and Play. So with IoT Plug and Play, you define, as a device developer, you define an interface, and it's basically a contract which describes the properties and the telemetry and the commands, and there's a schema for being able to define these. You can define what's called a capability model, which is a collection of interfaces which represent that thing. So, for example, it could be a device model for a sensor that you're bringing to the marketplace. And there is a description language to go and define these. It's actually called the Digital Twin Description Language. It's based on an open source standard called JSON, LD, and RDF. And you can find more about the specification in the link at the bottom of the page. Now, to give you an example here, this is actually the plug and play schema that I set up for the CSharp example that I demonstrated before. And you can see that I've got an ID for this schema, so these have to be unique. So this one here is called DTE MI Glovebox HVAC. And you'll see if I come down here that you'll see that there is a schema which describes the capabilities of the sensor. So in here you can see I've got a type called telemetry. The name is called temperature. The full display name is called room temperature. The schema is double, and the unit is Celsius. And the same deal for telemetry down here, which is pressure in this case, ambient air pressure, double, and HBA. So the idea behind this is that you can go in as a device developer, go and build a device and describe the plug and play model for your device. And then as a solution developer, you can go and build back-end solutions which accept plug and play specifications that automatically basically ingest the capabilities of that device and make it much more simple, making it simpler to go and build IoT solutions. So do check out Plug and Play because I think it's absolutely fascinating. Okay, so the last thing I want to talk about is something called IoT Central. Now, IoT Central is a fully managed IoT service, so no cloud development or expertise required. There is full support in there for devices, for monitoring. It's extensible, so you can extend the telemetry that's flowing into IoT Central. You can set it with flow, dynamics, webhooks, etc. There's dashboards, analytics, and it's really easy to get on board with and give it a try. Now, IoT Central itself is actually built on Azure IoT Hub. There's an implementation of plug and play built into it, and there's Stream Analytics underlying it, as well as Azure time series insights, and those building blocks go to make up IoT Central. So we're going to have a quick demonstration about how IoT Central works. Okay, so this is the IoT Central dashboard. It's fully configurable, and you can put information on there that you deem to be high priority. I've got a number of devices set up in here. The device I'm going to look at is a carbon dioxide monitor. If I go and click on that, if I can expand this, you can see that this is the readings of carbon dioxide in the room where I'm working over the last close to the last 12 hours. And you can see while I've been presenting, the carbon dioxide levels have really gone up to really quite unhealthy levels. I can go and look at analytics. So underpinning this is time series insights. I can look at the particular group. In this case, it's carbon dioxide. I want to look at the parts per million, analyze this. And you can see I can now drill into this. I can look at the last 7 days of data. This data is all real. And hey, look, I might be interested in this particular area and find out what was happening at that particular time. And you can kind of drill into that data. As I said, this is underpinned by time series insights. We have the concept of templates, and these templates are actually plug and play templates. So we have an interface, and that interface defines really the capabilities of this device. So you can go and express, in this case, the temperature, what the temperature looks like. If I click on that drop down, you can see that this temperature is of schema float, and the display unit is Celsius. The same deal for carbon dioxide. It's a schema's float. I look at humidity, and you'll see again the schema's float, and the display unit is a percentage. So that's a very quick introduction to Azure IoT Central. Do check it out, because it's a fantastic way if you want to go and quickly get solutions, IoT solutions up and running. It's all underpinned by all the things that I've been talking about: IoT Hub, plug and play, Stream Analytics. And it's a solution there that you can really go and customize, and it helps demonstrate the value that IoT can bring to an organization very quickly. Okay, so that's the end of the session. So these are the resources for the session. You'll find links to the slides, to the session code that I used, so the CSharp and the Azure Sphere C code to help you build applications which can talk to Azure IoT Hub. There's the resources there to the overall session, and do check out a series of curated links I put together for this session. So check out aka.ms/IoT20/learn. These are a series of Microsoft Learn modules which will really help you dig into building solutions and really understanding the data architecture for an application, for an IoT application. We also have something called the AZ220 IoT Developer Certification. That certification, absolutely fantastic opportunity to really learn across a whole range of disciplines for when you're building IoT solutions for Azure. So thoroughly recommend checking that out. And just those resources are all available as part of Microsoft Learn. So be sure to go and search for that and find an amazing set of resources to really help you in your learning journey with Azure. So thank you very much, and I really hope you enjoyed this session.